All right, we're going to start out section 9.10 with our calculators. I mentioned at the beginning of the chapter that you had sine, cosine, and tangent buttons on your calculator. So why don't you go ahead and grab your calculator so you can follow along. I don't have one I can show you in the video, but go ahead and grab one to follow along and make sure we're getting the same answers. So if you have to find the sine of angle 11, what you do on your calculator is you find your sine button, and you're going to type in sine, so hit that button, and then just type in 11. So if you do sine of 11 degrees, you should get, and on these we're going to round to 4 decimal places, so it's 0.1908. All right, some calculators, if you guys are using the TI-30, the blue one, and sometimes those come in other colors, that's how you're going to type it in. If you have a calculator where, for example, you need to type in a -3 and it has you do the 3 and then the negative button, so kind of in an opposite order, what you're going to do on your calculator is you're going to type in the 11 first, and then you hit the sine button, and it's going to give you that same 0.1908. One thing to notice on your calculator, if you look at it, it should say DEG somewhere on the screen. That stands for degree. If it says RAD or GRAD, you're in the wrong mode for your calculator. You're not going to get the correct answers if your calculator says that on it. So you want to make sure it says DEG, and to fix it, you can just reset the calculator, and the default is the degree mode, or you can go into your mode and switch it that way. So come see me if you have questions if you're not able to figure that out. All right, so the next one, tan of 24 degrees. So again, we find your tan button, tangent, type that, type in 24, hit enter, and round to 4 decimal places, you get 0.4452. Cosine of 70, find your COS button of 70 degrees, and you get 0.3420. And then again, we have our sine of 32, so find your sine button, hit 32, rounding to 4 decimal places, 0.5299. All right, so I do hope that you are following along with that, just so that you know how to do this on your calculator. That's kind of the goal of this intro lesson right here. All right, so moving on to example 2. Find angle A. Well, the difference here is, if you're using your calculator and you type in the sine button, you can't, you need to have an angle measure with that sine button. So if you notice, they actually told us what the sine value was. They said the sine of angle A equals 0.8481. See how that's kind of like these decimals we were getting up here when we found the sine? So I already know what the sine is. We're trying to find what the angle is. So if you're going backwards like this, you have a button on your calculator that will let you go backwards. So it's still the sine button, but if you notice above it, in kind of a different color, it has a -1. This is called the inverse sign. So you're going to have to type your second button and then get your sine button, so you're using that inverse sign, and then you type in 0.8481. So you do inverse sine of 0.8481, and we get, it's about, if I'm going to round to the nearest tenth, so it's still going to be just 58 degrees. So see if you can figure out how that works on your calculator, that's angle A right there, to get that same answer. I want to make sure you guys know how to use your calculators before you come to class. All right, so tangent of angle A. Again, on this, same idea, you're going to do the second button and then find that inverse tangent with that -1. It's going to be your tangent button. Type in 0.6494 Oh, that's okay. All right. So inverse tangent of 0.6494, and then see if you get the same thing. I am getting, well, it's 32.999. So I'm going to round to the nearest tenth, which actually just rounds this up to 33 degrees. All right, cosine of angle A, same idea. You're going to do your second button, then your cosine button because you want that inverse cosine function. Type in your decimal, 0.1045. So inverse cosine of 0.1045 gives us about 84 degrees. So if you know the sine, cosine, or tangent value and you're trying to find the angle, you just use the inverse functions, inverse sine, cosine, or tangent. All right, so let's figure out how to apply all this stuff now that we're back to our triangle. It says find the measure of angle B. So here's angle B right here. We need to know angle B is equal to what? So let's think about this right triangle and label our sides according to angle B. You got your opposite side across, so that's 24. The hypotenuse is 25, and the adjacent side is 7. So what we can do for angle B is actually use any of these. Let's just say we want to use the sine function. So sine is equal to opposite over hypotenuse. So we know that the sine of angle B, or I'll just say the sine of B, we'll know I'm talking about angle B. So the sine of B is equal to the opposite side, which is 24, over the hypotenuse, which is 25. Now I want to use my calculator to help me figure out what angle B is. So I'm going to use the inverse sine button. Anytime you're trying to find an angle measure, you're going to end up using the inverse sine. So I'm going to do the inverse sine of, and then in parentheses, I'm going to do 24 divided by 25. So on your calculator, that's exactly what you type in. You do the inverse sine, and then you're going to notice that you get a parenthesis right away. So you do 24 divided by 25, close the parenthesis, and it's going to tell you 73.7 degrees. So that's how we used our trigonometry to find angle B. All right, so let's look at angle C. Well, now we have to think about angle C is up here. The hypotenuse stays the same. I'm going to go ahead and just cross these off and rewrite this. Now the opposite side is 7, and the adjacent side is 24. So you can use sine, cosine, or tangent if you have all three of your sides. So let's say we want to do sine of angle C. Well, we know the sine of angle C is the opposite over the hypotenuse, so 7 over 25. Now to actually figure out what the angle is, we bring in our inverse button. So we're going to do the inverse sine of that 7 over 25, and the answer we get back will be our angle measure. So you have to do second sine, you type in 7 divided by 25 in the parentheses, and it's going to give you, rounding to the nearest tenth, 16.3 degrees. All right, our fourth example. So we have to find x. We're trying to find our side length over here. So we're going to set up one of our trig ratios to help us figure this out. So let's focus on the fact that we know that this angle is 36 degrees. So if we label our three sides, across from 36 is the opposite side. We know our hypotenuse is across from the 90 degrees, and then that leaves the third side as the adjacent side. Right now, we do not know what the adjacent side is, so I'm not even going to worry about that. I'm going to focus on the fact that we want the opposite side and we know the hypotenuse. So if you think about SOHCAHTOA, which one, sine, cosine, or tangent, uses the opposite and the hypotenuse? And if you look at all those, the opposite and the hypotenuse are used with the sine function. So we are going to set up our trig ratio. We're going to say the sine of our angle 36 is equal to the opposite side, which is x, over the hypotenuse, which is 30. Now we have a little mini equation that we can use to solve and find the value of x. I think it's helpful if you see this as a fraction over 1. What that's going to let us do when we solve for x is cross multiply like this. So we're going to multiply this side, x times 1 is just x, is equal to, and we're going to multiply this side. I'm going to put the 30 out front. It's going to be 30 times the sine of 36. So that's 30 times the sine of 36. We're going to use our calculators. Just type in sine of 36. Round to 4 decimal places, you get 0.5878. And then we're going to take that and multiply it by 30. And x is equal to 17.6. So hopefully it made sense why we use the sine function versus the cosine or tangent. We had to look at the information we were given. We had the opposite and hypotenuse sides, and sine is the only one that uses the opposite and hypotenuse together. All right, example 5, same idea, so we're just going to go through this again. It's good practice. We are trying to find y. We are given an angle, so let's go ahead and label our 3 sides. Across from the 40 degrees is our opposite side, so our opposite is 20. We know the hypotenuse is always across from the 90 degrees, and that's leaving y as the adjacent side. Now, I'm not going to worry about the hypotenuse because that side is not labeled. We're going to focus on the opposite side and the adjacent side. So go through in your head again. We know we're going to use SOHCAHTOA. So one of these uses the opposite and the adjacent side. So it's not going to be sine that uses the hypotenuse. Cosine uses the hypotenuse, but tangent uses the opposite and the adjacent sides. So when we set this up, we're going to say tangent of our angle 40 degrees, so tangent of 40 is equal to the opposite side, which is 20, over the adjacent side, which is y. Now we just solve this little equation. Again, go ahead and give yourself a fraction so you can cross multiply easily. So when we cross multiply with that y, put the y out front, so it's going to be y times the tangent of 40 is equal to 20 times 1, which is 20. All right, so let's figure out what the tangent of 40 is on our calculators. So we just type that in, tangent of 40, round it to 4 decimal places, 0.8391 is equal to 20. So how do we get the y alone? It's being multiplied by that 0.8391. So all we're going to do is we're going to divide both sides by that 0.8391. So that cancels, and that leaves us with y is equal to, and then we just type that in your calculator. 20 divided by 0.8391 gives us 23.8. All right, here's our last example of this intro video. We are trying to find z, and what's different about this one, if you notice, z is an angle measure. Anytime you're trying to find an angle measure, you're going to use either the inverse sine, inverse cosine, or inverse tangent button on your calculator. We'll figure out which one we're going to use, but that's just where we're heading with the problem. So we're going to focus on angle z, label your 3 sides. Across from angle z is 4, so that is your opposite side. Your hypotenuse is across from the 90 degrees, so your hypotenuse is 90, leaving 3 as your adjacent side. All right, so because all 3 sides are labeled, it honestly doesn't matter which one you use, sine, cosine, or tangent. So if we think about SOHCAHTOA, maybe you have a favorite, I don't know. Let's go ahead and use cosine. I don't think we've used that one in a couple examples. So cosine of our angle z is going to be equal to the adjacent side, which is 3, over the hypotenuse, which is 5. Now, we know that cosine of z equals 3 over 5. Because we want to figure out what angle Z actually is, we're going to use our inverse cosine button. So we did this a couple examples ago. You do inverse cosine of 3/5, and that's what you're going to type in your calculator. So remember, you have to use the second button. So second cosine, and then 3 divided by 5 goes in your parentheses. That equals Z, by the way. So Z is equal to 53.1 degrees.